Hello guys, Winston here. Just when I thought I was out of stock, they pull me back in. My friend Manthan told me he was planning on getting engaged, and he asked me if I could make him a ring box. And despite having sworn off making sellable things like this, I couldn't turn a bro away. So here I am revisiting an old project, which I guess I'm okay with because that means I can put a new twist on things. For those of you who need a refresher, about 2 years ago, my old roommate wanted to propose to his now wife on a road trip and needed a slim ring box, so I machined one out of some sort of mahogany lookalike, sold a few on Etsy, and called it a day. It was a decent design that was simple, clean, and easy to machine, though it required a couple tool changes. This time around though, I wanted it to be a one-cycle start wonder. No tool changes, just a single setup and no machine tending. So that required modifying my ring box design and improving a couple things. The most important thing to do was to increase the radius of the corners so that they could be comfortably machined with an 1/8 inch end mill. Those corners should be noticeably larger than the radius of the end mill cutting it, not just barely larger. I usually try to oversize them by at least 20%. I also wanted to recess my magnets a couple thou deeper to guarantee that they were fully seated in their pockets. A number of factors like sanding after machining or glue pooling up underneath the magnets when I install them would all end up pushing the magnet to sit slightly proud, so a 70 or 75 thou pocket would ensure that my 16th inch thick magnets wouldn't be sticking out. Between recessing the magnets and extending the lip around my lid, I could force a small air gap between the magnets and tune the force required to pry the box open. Magnetic attraction decreases exponentially with distance, so that tiny gap will cause a slight reduction in how well the box halves stick together, which was a bit stronger than it needed to be. That makes the act of revealing the ring inside just a little bit smoother. I decided not to add a fillet around the top and bottom edges. This serves three purposes. 1, it means the ring box will sit more stably on a flat surface. 2, it means the ring box definitely won't be mistaken for a case of AirPods when you reach into your pocket. And 3, it means I don't need to round over the top edge either manually or on the CNC. That saves me time and effort. But obviously, my primary motivation for this design change was noble and had nothing at all to do with my laziness. That basically wrapped up my CAD tweaks. On the cam side, the machining process really didn't change much at all except for changing all my tools to 1/8 inch. The order of operations was more or less identical to my first ring boxes: face the material down to an exact thickness, pocket out the main cavity, add details, and then cut around the outside. On the Shapeoko, I taped down a slab of 3/4 inch walnut, zeroed off the wasteboard, and started machining. Because I was machining both the base and the lid simultaneously, there was no way for me to gauge the fit of the two halves until they had been liberated from the stock. The lid was a little tight, so I made another set with an extra 3 thou of margin around that interface. Now, on my original ring boxes, I had engraved the couple's initials on the lid and then filled the letters with paint. My friend inquired about gold paint as opposed to black or white, and while I could have obliged, I just don't think that gold looks good in paint form. However, you know what does have a proper hue and looks classy as hell when paired with walnut? Brass. So I elected to inlay the initials in brass, which meant breaking out some really tiny end mills. The inlay pieces were modeled by first laying out some text, extruding them out to a thickness of 0.5 millimeter, and then carefully filleting or rounding over all the corners. I would have to cut both the inside and outside of the shape to match so that there couldn't be any sharp angles. Also, note here that for the inlay pieces, I'm doing the A in a separate setup from the M and ampersand. There's not enough room for an end mill to pass between the ampersand and the A, and I don't want to put a space in there because I'm also using this model to pocket out the walnut to receive the brass, and the spacing needs to be correct. I loaded up this 15 thou end mill, which you would have seen before if you're subscribed to the Carbide 3D channel, and let it loose on some brass that I had faced down to a known height. And did you catch that? The tip of the tool broke off almost immediately. I was kind of expecting this because of the runout of the router. Even on their best days, most palm routers don't get less than about 1.5 thou, maybe 1 thou of runout. In my book, anything more than about 5% of the diameter of the tool in runout is a recipe for disaster. So 1/32 of an inch, maybe 25 thou if your router is exceptionally straight, is the smallest tool I can recommend on a conventionally equipped Shapeoko. Having run into the limits of what I could machine on the Shapeoko, I brought my brass and walnut to work so I could bring the Nomad to bear on this problem. I was being super conservative with this end mill since I only had 2 left, and every mistake costs $15, 10,000 RPM, 5 inch per minute feed rates, 4 thou or 0.1 millimeter step down. I'm doing this with a roughing pass enabled, so at every step down I'm taking a pass leaving 3 thou of stock to leave, and then immediately doing a finishing pass afterwards. I want to finish as I go because there's so little surface area on these letters that they're going to be very delicately attached to my table once I break through the bottom of the brass stock. This ended up working out way better on the Nomad than the Shapeoko. I deliberately cut the brass letters first so I could test fit them into the lid and tweak my stock to leave for a snug fit. It didn't take much, about -1 thou stock to leave got it so I could easily inlay the brass without leaving any visible seams. I brought the pieces home so I could glue the inlays with CA glue, sand everything flush, and then immediately lacquer the ring box while the brass was still shiny. With the walnut sealed, I then moved on to installing the magnets and the ring retention mechanism. Is there a technical term for this thing? Whatever. The slit where you shove a ring. I like to use a soft canvas-like ribbon that I bought from a craft store, folded in such a way that I don't need to do any sewing. Squirt some of your preferred adhesive into the ring hole, insert the fabric plug, and let it sit overnight. If you're using E6000 like I am, I highly recommend letting it sit for at least 48 hours before using, unless your significant other likes the smell of organic solvents, which, I mean, you can't rule that out. My ex, for one, seemed to be confoundingly immune to the smell of nail polish remover. Anyhow, give E6000 the full cure time and you'll be good to go. And just like that, you're done. Really, nothing new here except for the integration of the brass inlay. But I think the finished piece looks pretty darn cool for it. The level of detail and seamless integration of the brass inlay is just really satisfying. I want to thank you all very much for watching. Manthan, I wish you and your fiancé the best, and I'll be back soon with more CNC projects and DIY shenanigans.